Howdy. Once again, mountain water, wide rivers. This time we go to Alaska, where we had some hours ago Yakutat, Alaska, 5.16 hours ago, 11 kilometers in depth, 20 kilometers in depth, 2 user reports. Is there anything interesting? Initial jolt, hanging object slightly moved for a couple minutes. Couple of minutes. Really? So I have been watching this region, and you don't have to be very careful in order to notice these. Let's go over to Google Earth and check them out. It's somewhere here. That's rather fascinating. That's really fascinating. That's very fascinating. I also noticed that as closer you zoom in, the more distracted the pictures get. We have very interesting formations here. Very interesting. We have very good quality as well, at least in some parts. And you can see the different kinds of sediment, different colored sediments, how they have distinctive boundaries. Layering. There's also water bodies. And obviously we are looking at a glacier. I didn't find yet too much things about this particular structure. There are a few pictures which are available from this. That's very interesting. And the layering is just continuing. And the whole flow seems to originate from somewhere here and it goes here. No, that's a landscape. Malaspina Glacier. Yes, I have to probably check it out somewhere. But before we do that, I just want to point out that the quake was somewhere here, I guess. And here, and here, and here, and here, and here. What do we have here? Check it out. A wide river. Wide rivers, glaciers, volcanoes. I still think that the glaciers might be contemporary lava streams made of water. Limestone environment. Here we have a bit reddish, which might indicate iron. Yeah, it has the same meandering pattern like many of those wide rivers do. I think that's due to the water flow. This might be a valley like this, and now the sediments cover it all up, almost horizontally, of course, leveled, and then the water is just meandering through those leveled surfaces. So this valley might have been much, much deeper. Once upon a time. It gets just filled up every now and then. Root glacier, glaciers, many glaciers. Glacier Lake. Glacial lakes, or the lakes where the glacier once started. Often they have a caldera shape, which is also rather an interesting feature. And this seems to be like the place where the glacier is ending. And usually there is also water flowing out of those places. And now we get a bit better glimpse at that. So if there has been once much more water and there was also sediments within the water, this could probably explain that how we can have dark and white rocks side by side. The darker ones are the elderly ones, they got transmuted by electromagnetic energy. And the gravel on top is probably some eruptive material which got deposited on top of that. So maybe we have to check out this other glacier. That's a very interesting place. And somehow how this looks, just the look, the layering and all this kind of stuff. This reminds me, now let's go quickly over to Denmark. Where is it? Here. Hornfitskron, which is here. It has, in a way, a similar appearance, like the glacier we just watched. Or does it? In my opinion, it does. There's many similarities. So, question remains, are these places where we have some kind of eruptive activity, hence volcanic activity? It doesn't have to be always hot and lava and these kind of things. So we have to check out the Malaspina Glacier. Malaspina Glacier in the southeastern Alaska is the largest Piedmont Glacier in the world. Now, there are a few different kinds of glacier types. And Piedmont Glacier isn't basically an own glacial form, it's just a part of a bigger glacier. But anyway, situated at the head of the Alaska Panhandle is about 65 kilometers wide and 45 kilometers long, with an area of some 3,900 square kilometers. Type. Now let's check out this Piedmont. It's basically when it gets pushed further out. Elephant Foot Glacier. Piedmont glaciers are a subtype of valley glaciers which have flowed out onto lowland plains where they spread out into fan-like shape. Some examples of Piedmont glaciers include Malaspina Glacier, Endeavour Piedmont Glacier, Antarctica. So the question remains, flowed out onto lowland plains where they spread out into a fan-like shape. How? If they don't flow, do they get pushed? And if they get pushed, what is the pushing force behind it? Is there anything pushing? Like a lava stream gets pushed forwards? I would say this could very well represent a lava stream. We have this kind of colored water here, and we have all those sedimentary outflows here, which are coloring the water. They are gray rivers, not white, but nonetheless, it's a darker white river. It is very interesting. I think there's something pushing. There is much more behind than just accumulation of snow and ice, which is making glaciers. And hopefully my paper is coming out soon, then I can refer to it. The Malaspina Glacier actually comprises Seward Glacier, Agassiz Glacier, and Marvin Hayden Glacier, which converge as they spill out from the St. Elias Mountains, onto the coastal plain facing the Gulf of Alaska between Ice Bay and Yakutat Bay. Officially, these three glaciers are classified independently, such that Malaspina Glacier does not technically exist. What? All right. We have again contradictions in consensus theory. We are talking about the glacier which does actually not exist. Yeah, like bright black holes. But anyway, the three glaciers are almost always referred to together, though sometimes only the largest primary Piedmont lobe is referred to as Malaspina Glacier. This notable feature is actually part of Seward Glacier. Like I said, like when I was talking about Piedmont Glacier, they are just part of a bigger one. Now we are talking about this again. And Marvin Hayden Glacier constituting the smallest and most eastern lobe. All through the glaciers fill the plain. Now, nowhere do they actually reach the water, and so do not qualify as tidewater glaciers. Notably, both Seward Glacier and Marvin Hayden Glaciers terminate near Malaspina Lake, formed during a previous advance. Neither glacier actually terminates in the lake, and therefore are also not classified as lacustrine glaciers. The Malaspina is up to 600 meters thick in places, with the elevation of its bottom being estimated to be as much as 300 meters below sea level. There are two lakes on its margins. Oily Lake to the northwest at the foot of the Samovar Hills between the Agassiz and Seaweed Glaciers, and Malaspina Lake to the southeast close to Yakutat Bay. Nearly all of the glacier is encompassed by the southeast lobe of Wrangell St. Elias National Park Reserve. So we have to go back to this and check out. Now, I was actually watching this earlier. Because just there being a lake and the land tongue between this. If you think about how glaciers are explained, usually, that they... Let me draw. I'm not a good drawer. So that's landscape. Let's draw a sky. Here we have the sky. And that's all land mass. And according to common theory, glaciers carved out all the valleys. Let me draw a valley. Or many valleys. Within we have the glacier, which carved out all the stuff over millions of years. I just have to ask if they are really created, or if they were really creating all those valleys. Where is the pile of the valleys? There should be a very big pile of rubble somewhere. So big that you could fill all the valley. It should be as big as the glacier itself. And we would expect that the glacier just would plunge over that into the sea, but we have land here in between and the lake. So how comes that there is nothing carved out here? There might be water bulging up on these spots as well. And we have to rely on what we see because that's just Google Earth. This water might contain gypsum. Much more than this. This seems to be more or less pristine. So we have different kind of waters here. Maybe it's not so, because we are watching some satellite pictures, which are a little bit funnily colored. Yeah, that's all very, very interesting. But I think I will leave it here. This might be ice. Yeah, that's very fascinating. Yeah, this would be a very interesting place to go around and check it out. This might be all ice, I don't know. Yeah, maybe someone else is talking about this still today and knows more about it. So here we have a 5.1 in Yakutat, Alaska. Glacial quake and wide rivers and all these kind of things. Very interesting. Thank you. Bye.